Good afternoon, everyone. Myself P. Shaduka, a BTech third year student of Andamas University, Kolkata. So, first of all, thank you to all to hackathon team judges for inviting me for this hackathon and create a real world product for scams and threat. So the problem is security teams today are drowning in alerts. The average SOC analyst receives over 500 alerts per day and spends hours manually triggering, correlating and writing incident reports. By the time a brief reaches the CISO, the attacker has already moved laterally across the network. ThreatBrief fixes that, from raw Splunk alerts to a complete incident brief in under 60 seconds. Problem statement. So the core problem is that Splunk gives you the data, but it does not tell you the story. Analysts are left manually connecting the dots, correlating timestamps, mapping MITRE techniques, extracting IOCs, and writing reports by hand. That's hours of work per incident. ThreatBrief automates the entire post-detection workflow using a multi-agent AI pipeline. So let's go walkthrough of the product. So here is the product. I am running it locally. So on the left, I have three pre-loaded attack scenarios pulled from our Splunk Enterprise instance, that is brute force, lateral movement, and ransomware. I will select ransomware indicators a scenario involving shadow copy deletion, mass file encryption, and network share lockout. I click analyze the threats, watch the pipeline, point to stepper. 5 AI agents of fire in sequence. Ingester normalizes raw alerts. Trigger classifies severity. Indicator maps MITRE attack techniques. Analyst reconstructs the attack timeline, and writer generates the final brief. All powered by NVIDIA NIM, running Llama 3.1 70 billion model. So on the right, we have MITRE attack technique badges. T1490 inhibit system recovery. T1486 data encrypted for impact. Each badge links directly to the MITRE knowledge base. And the confidence score 91% with the model's own reasoning for why it reached that verdict. So we will see the live demo. So here you can see that I have a toggle button. So here it will fetch the alerts logs from this Splunk, and here we will hit fetch and analyze. So as I will hit, so the 5 AI agents I have created will trigger out. So here you can see that first ingester agent. So it the data is ingested. Now the trigger, and now the integer agent. So ThreatBrief is different from a report generator because every brief is interactive. I can ask it directly, what should I isolate first? It answers grounded in this specific incident, not a generic advice. Specific host, specific actions, specific sequence. This turns a static PDF into a live analyst you can interrogate. ThreatBrief also connects directly to Splunk Enterprise via the REST API. I toggled live Splunk mode. It pulls real alerts from the index in real time, runs them to the same pipeline, and generates a brief from actual production data. No copy paste, no manual export. Then under the hood, fast API backend, LangGraph orchestrating the 5 agents pipeline, NVIDIA NIM providing the interference layer, and Splunk Enterprise as a data source. The entire stack runs locally, no third-party data exposure, built for security team that cannot send alert data to external APIs. So here you can see that we have got the output. Here is the confidence score is 95% due to the clear evidence of data exfiltration and the attacker's use of valid accounts. So here the affected you can see the affected systems, and here are the indicators of compromise, and here is the timeline and here you can ask questions. Thank you.